All right, this is 7.1 review for Math 2, and we're talking about right triangles. This entire unit is about right triangles, and we're talking about Pythagorean theorem right here. And remember, Pythagorean theorem can be written as c squared equals a squared plus b squared. Of course, you'd want to use that when you're trying to solve for the hypotenuse c. Or more traditionally, you see a squared plus b squared equals c squared. Depending on what you're looking for is depending on which way you'd want to write it down. So number one, we see the hypotenuse of a right triangle. The hypotenuse of a right triangle with legs of length 5 and 12. So we want to find the c. So in this case, we would use this guy right here. So we'll say c squared equals 5 squared plus 12 squared. So we get c squared equals 25 plus 144, which means c squared equals 169. We take the square root of both sides because we don't want to know what c squared equals. We want to know what c equals. And the square root of c squared is just c. What we do to one side, we have to do to both. And the square root of 169 is 13. That's one of those Pythagorean triples we talked about. 5, 12, 13. Okay? A diagonal of a rectangle with a width of 7 and a length of 12. All right, so we have a rectangle here. And we have a width of 7 and a length of 24. Excuse me, I said 12, I think. And they want to know what the diagonal is. Well, hopefully you can see that the diagonal is c. So again, we'll say, by the way, that was 13 up there. We'll say c squared equals a squared plus b squared, which means c squared equals 7 squared plus 24 squared. So we have c squared equals 49 plus, what is 24 squared? 576. Out of practice, 576, which means c squared equals, let's go, plus 49 equals 625. And of course, the square root of 625 is 25. Oops, I forgot. I take the square root of both sides, and then we get c equals 25. Okay, so that's actually another one of our Pythagorean triples. I usually don't memorize those, but 7, 24, 25 is a Pythagorean triple because it comes out perfect. Okay, a diagonal of a square with sides of 12. Well, this is pretty easy. You would have had to do the work. You would have to use Pythagorean theorem a couple days ago, but now you know a special right triangle. Okay, a square has sides of 12 and 12. Well, you know that's a 45, 45, 90 right triangle, which means the hypotenuse is 12 root 2. All right, moving on. So solve for the missing side. And again, something I've mentioned before, that in this unit you're going to have a third of the questions are going to be using Pythagorean theorem. Whenever you're given two sides and asked for the third, you always want to use Pythagorean theorem. So this one would be x squared plus 12 squared equals 16 squared. So that's x squared plus 144 equals 256. Subtract 144 from both sides, and we get, what do we get? 112. We'll take the square root of both sides. And what is the square root of 112? Let's see if that simplifies. Sure it does a little bit, 4 root 7. So the square root of x squared is x, and the square root of 112 is 4 root 7. Okay. This is the hypotenuse, so we'll use c squared equals a squared plus b squared, which means x squared equals 5 squared plus 10 squared. So x squared equals 25 plus 100, which means x squared equals 125. We'll take the square root of both sides. Square root of x squared is x, and the square root of 125 is 5 root 5. Okay. Moving on to number 6 and 7. All right, since this is a square, these two sides are congruent. So again, we're looking for the hypotenuse, aren't we? So c squared equals a squared plus b squared, which means x squared equals 3 squared plus 6 squared. X squared equals 9 plus 36, which means x squared equals 45. Take the square root of both sides. Square root of x squared is, just x. And 45 is 9 times 5. So the square root of 9 is 3 root 5. All right, now this one we got to do a little work. We need to find this side so that we can use it in Pythagorean theorem to find this side. So basically what we have is 3 squared plus x squared equals 5 squared. And that's x right now. That's temporarily x. In fact, let's not call it x. Let's call it b. Okay, so we have 9 plus b squared equals 25. Subtract 9 from both sides, we get b squared equals 16. Take the square root of both sides, and we get b equals 4. Okay, so this guy is 4. Now, this is why I'm talking about it's a good idea to memorize some of the basic Pythagorean triples, because a 3, 4, 5 is a Pythagorean triple. So if you had memorized that, you wouldn't even have to use the Pythagorean theorem. You just know that if this side is 3 and the hypotenuse is 5, then this leg has to be 4. All right, but now we have this information. Since this is the hypotenuse, we'll use c squared equals a squared plus b squared. We'll plug in x squared equals 4 squared plus 7 squared, which means x squared equals 16 plus 49, which means x squared equals, what do we got? 65. So we'll take the square root of both sides, and we get x equals, what do we get here? 13? Or I'm sorry, square root of 65. Sorry, I was thinking ahead. 65 is 5 times 13, so we can't simplify that. All right, last 3. Find the value of y expressed in simplest radical form. All right, hypotenuse. So c squared equals a squared plus b squared. So c squared equals 5 squared plus 10 squared. So c squared equals 25 plus 100. This one sounded familiar. C squared equals 125. Take the square root of both sides, we get c equals 5 root 5. Okay, we'll call this b. So a squared plus b squared equals c squared, or 6 squared plus b squared equals the square root of 85 squared. So 36 plus b squared equals, well, the square root of 85 squared is just 85. So we'll subtract 36 from both sides. We get b squared equals, what do we get, 49? Take the square root of both sides, and we get b equals 7. All right, last one. So this is, we'll call this b. So it's a squared plus b squared equals c squared, or 11 squared plus y squared equals 61 squared. So 121 plus y squared equals, let's see here, 61 squared is, 3,721. Subtract 121 from both sides, we get y squared equals 3,600. Take the square root of both sides, we get y equals, well, the square root of 36 is 6. So the square root of 3600 is 60. All right. Hopefully that was helpful. I went kind of quick, but hopefully I got all the correct answers there to help you out.